Example 4, when I look at this polynomial function, remember the first thing that you should always do is check for a GCF. And there is a GCF of 2. Now I do want to mention, and this was a common mistake that I've seen in the past, we would like this first term to be positive. So if this is a negative 2, I should pull out that negative 2 to make it a positive 1x squared after pulling out the GCF. That does mean that all of the other terms will not only be divided by 2, but also there will be a sign change. So essentially what we end up with is x cubed plus 6x squared minus 9x minus 54. Now this, what's inside of the parentheses, is what we would like to factor. Because there are 4 terms, we are going to be factoring by grouping. So I'm going to multiply negative 2 by, I'm just going to put a bracket. It's going to help me organize it a little bit better. Looking at the GCF of the first 2 terms, I see that that would be x squared with x plus 6 remaining. And then looking at the negative 9x minus 54, they both are divisible by 9. But if I just pulled out the 9, I would have a negative x minus 6. That does not match what is in these parentheses. So let's pull out a negative 9. So that way I'm left with x plus 6. All right, now we're able to rewrite this as negative 2 times x plus 6 times x squared minus 9. It is now a quadratic function right here, so we can factor further, and we must always factor further if we can. This is a difference of 2 squares, so my final factored form would look like this. We now need to set each term equal to 0. Negative 2 does not ever equal 0, so in this case the GCF does not give us a 0, but each of these binomials will. There are zeros of negative 6, negative 3, and positive 3. Keep in mind, our original polynomial was to a degree of 3, so we should have 3 zeros. We're now going to check with Desmos just to make sure that our graph looks good, and we're going to sketch a rough graph. So I have Desmos pulled up and my function plugged in. If I click on the graph, I can see that my x-intercepts are in fact a negative 6, negative 3, and positive 3 like we said. And just to get the shape, I'm going to zoom out a little bit so we can see how it looks. Okay, now that I see that, I'm going to go back to my notes and draw a rough sketch of this. Here's my rough sketch of example 4, and I want to talk about the behavior really quickly. This is something you'd explore more in a class like pre-calculus, but because both of these were originally odd powers, we see different end behavior, meaning that one end of the graph is going down and the other is going up, or in this case, up and then down. Now the A value was initially positive because we can see it was a positive 1, which is why as it moves to the right it's moving up. In example 4, the A value was initially negative, which is why it's opening down. I'm not going to test you over that right now. I just wanted to point it out. I'm going to point out something else after some try problems. All right, example 5. We have x to the 5th power plus 6x to the 4th power plus 9x cubed equals 0. The very first thing that I notice is that there is a GCF here of x cubed. So let's go ahead and pull that out. X cubed, x squared plus 6x plus 9 equals 0. Once we pull out that GCF, we now have a quadratic function that we should know how to factor. Because a is 1, I'm just going to use guess and check. The factors of 9 are 1 and 9, 3 and 3. But I want a positive 6, so I would have to use x plus 3 and x plus 3. We need to bring down that GCF, set it equal to 0. Now, because we have a degree of 5, we should list out 5 zeros, okay? Because this is x cubed, we're going to have a 0 of 0 3 times. X plus 3 set equal to 0 would be a negative 3. X plus 3 set equal to 0 would be a negative 3. Let's talk about multiplicity for a minute. I forgot to do it on example 4, so I'm going to pop back up real quick. Because each of these were only written once, it has a multiplicity of 1, and because that's odd, it's just going to pass through, which is what we did see when we drew our rough sketch. Each of the x-intercepts have the graphs passing through it. However, in example 5, we have 0 listed 3 times, so it has a multiplicity of 3, which is an odd number. So because it's odd, I know that when I see the graph, it should be passing through the x-intercept of 0. But the negative 3 has a multiplicity of 2 because it's listed twice. Because that is an even multiplicity, that means it's just going to come up and touch that x-intercept. Let's graph it in Desmos and see if this holds true. Alright, so I'm in Desmos. Here's my equation right here. I can see that I do have 2 x-intercepts of negative 3 and 0, because remember, even though we have 5 zeros, I may actually only see 2 x-intercepts. We said negative 3, since it had an even multiplicity, it would just come up and touch the x-axis, which it does. Then it goes down and comes back up to the 0. At 0, it passes through because it had a multiplicity of 3, which is odd, but also because that multiplicity is greater than 1 and odd. Notice how it slowly bends around that x-intercept, sort of looking like a cubic function, right? How it slowly approaches the x-intercept and then goes back up. So I pop back over to my notes, just did a rough sketch showing my 2 x-intercepts, and I did a very poor job, but you can kind of see it how it starts to bend around that x-intercept of 0. You are now going to try C and D, so pause the video, attempt those problems, and hit play when you are ready to check your work. Feel free to pause the video now that my solutions are up to check all of your work. For C, you should have pulled out a GCF and just use basic guess and check. Because there is a degree of 6, you should have 6 zeros listed out. 0 is listed 4 times, so it has a multiplicity of 4, meaning it's going to touch the x-axis. Negative 3 and positive 2 I got by setting the binomials equal to 0, meaning they're going to pass through the graph, which I see here. Okay, there's my rough sketch. Again, feel free to pause it so you can check your own sketch. It doesn't have to be perfect, but I do need to see the x-intercepts and whether or not it's passing through or touching. For D, even though it was to a 4th power, it was a trinomial, so you should have just used guess and check like we normally do. Instead of having x and x here, though, we would have x squared and x squared. Both of these ended up being perfect squares, a difference of perfect squares. So we would end up with this factored form here, which gave me 4 zeros, which makes sense because if I go back, I can see that our original degree was in fact 4. Each of these is listed once, so it has a multiplicity of 1 for each term. And if you went on Desmos, you would see that that is in fact true. Now, I want to talk about end behavior really, really quick. On the front page, we had odd powers, which is why our end behavior was different, going up or down in each direction. Here on the try problems, we had even powers, so 6 and 4, and because they were even powers, we had them going in the same direction for the end behavior, so up and up. If it would have been opening down, it would have been down and down. And remember, what determines if it opens up or down to the right is the A value. Both of the A's were positive. I have a positive 4 and a positive 1, meaning that, like I said, it's opening up and up. All right, last bit of information here. It's essentially what I've already been talking about. When we are trying to determine the zeros or see how the zeros are represented, you can either see it on a graph or in the equation. It's better to have the factored form to determine multiplicity, but we can have a general idea by looking at the graph. So when I look at a graph, we would want to look at the x-intercepts, the number of x-intercepts. I have an x-intercept at -2, -1, 0, and 1. However, I know that this is not a degree of 4 because first off, look how the graph is behaving. Down and up. Different end behavior. So I know that this must be some odd degree, even though I only see 4 x-intercepts. So what could happen here is that one of them must have had an even multiplicity. So if it's even, remember, it's going to touch the x-axis. If it passes through, it's odd. So we'll say a minimum of 1 degree here, 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 and then at the x-intercept of 1, notice how it touches. So I know the minimum degree here is 2. So 1 plus 1 plus 1 plus 2 gives me a degree of 5. And that's, again, a minimum degree. All I know is whether or not something's odd or even just by looking at the graph. So again, not the best. It's better to have that factored form or even just the equation. We can tell how many zeros there are based off of the highest degree. So 5 here, and then if it's in factored form, we would just add the exponents. So x to the first power squared, first power, first power. 1 plus 2 plus 1 plus 1 gives me a degree of 5. And once again, just because I'm going to have 5 zeros does not mean that I'm going to see 5 x-intercepts. In fact, this polynomial factored is this, and when we graph it, this is the actual graph. So we do see, even though I have 5 zeros, I do not have 5 x-intercepts. I would have a 0 of -2, -1, 0, 1, and 1 because it touches here. -2, -1, 0, 1, 1.